We will continue the topics from the previous discussion, weldability. So let's go. What is good weldability in steel? Good weldability in steel signifies the material can be readily joined by common welding techniques without requiring special procedures to avoid defects. This characteristic is primarily found in low-carbon steels, where a low-carbon equivalent minimizes the risk of forming hard, brittle microstructures in the heat-affected zone, HAZ, that lead to cracking. A steel with good weldability forms a sound, strong joint with mechanical properties matching the base metal, including consistent strength and toughness. It demonstrates high resistance to common issues like porosity, solidification cracking, and hydrogen-induced cracking under standard welding conditions, ensuring reliable and economical fabrication without the need for extensive pre- or post-heating treatments. What is poor weldability of steel? Poor weldability describes a material's tendency to form defects during or after welding, making it difficult to achieve a sound, reliable joint without extensive precautions. Such materials, often high-carbon or high-alloy steels, are highly susceptible to cracking in the heat-affected zone, HAZ, due to the formation of hard, brittle microstructures. They are also prone to other flaws like porosity and incomplete fusion. Mitigating these issues typically demands complex, costly procedures such as strict preheating, precise post-weld heat treatment, PWHT, stringent control over interpass temperature, and the use of low-hydrogen electrodes. Even with these measures, the resulting weld may still exhibit inferior mechanical properties, compromising the integrity and service performance of the fabricated structure. Poor weldability directly results in cracking, a critical and common defect that severely compromises joint integrity. This occurs because susceptible materials, like high-carbon steels, form hard, brittle microstructures in the heat-affected zone, HAZ, during the rapid thermal cycles of welding. These regions, lacking ductility, are highly prone to hydrogen-induced cold cracking and solidification cracking under residual stresses. Preventing such cracks demands extensive measures, strict preheating, controlled interpass temperatures, and precise post-weld heat treatment to soften the HAZ and allow hydrogen diffusion. Without these rigorous procedures, the welded structure is at high risk of catastrophic failure. How to measure weldability? The phrase means weldability cannot be defined by a single, universal measurement or an absolute scale. Instead, it is a comparative property evaluated by ranking materials against each other under specific conditions. This relative assessment is necessary because weldability is not an intrinsic material attribute, but a complex interplay between the base metal's composition, the welding process, joint design, and service requirements. A steel's performance is judged relative to another. For instance, low-carbon steel is known to have better weldability than high-carbon steel. This comparative approach allows engineers to make practical, contextual decisions about suitable procedures, necessary precautions, and the expected fabrication effort for different materials, ensuring a more reliable and realistic evaluation.